All right, so surface area of prisms and cylinders we're talking about today. Like I said, we'll kind of see how time goes. All right, so our perimeter and area. Now our area is 1/2 ANS. Now this is one we're gonna have to find that little a. And doing this is gonna be a good review because we do need these for some of our shapes that we'll be doing. Think about some of our prisms we need to find the area of. Now the good thing is they tell us the number of sides and they tell us the side length. They're actually both 8. If you count this, so this is 8 sides. And then the side length is 8 inches. So we need to find little a. And if you guys recall, that's where we go through the center. Now technically they also ask for the perimeter, and we actually already know the perimeter in this case. The perimeter, all of these would be 8. Because this is a regular polygon. So our perimeter would be 8 times 8, which is 64. So the perimeter is actually pretty easy in this one to find. And we'll be using the perimeter a little bit today in some of these. Now little a we have to find is here. And remember, we have to draw this triangle in. And so again, this is a bit of review from last chapter, and definitely a tougher idea. Is we have to do 360 divided by the number of sides, and I'll get 45 degrees. But remember, that's only half of that top, or that's double the top angle up there. So technically, the angle we're looking at is 22.5. The side across from it would be 4, it'd be only be half of that, and we're trying to find little a. So this is opposite, this is adjacent, so we're going to do tangent. Now we kind of did one like this, I think yesterday, where we had to find the value of the variable when it was in the denominator. So ones like this, I suggest we use proportions. Otherwise, you could also change your perspective. And I find out little a is like 9.66. And then we multiply all of these together and then divide it in half. So our area ends up being 309.0 essentially, or 0.2. Okay. So we're talking about surface area today, and what surface area is basically, and this is actually something that, and I don't know if this is what Mrs. Hoffman's husband does for a living. I think he does. He does the kind of engineering. We're talking about packaging things in a smart way. So like how, I believe that's what he does from what I can remember of us talking about it. So like talking about how much paper it would take to like make this Kleenex box in like the most efficient way. So the fact that he needs to like have it overlap a little bit, but at the same time you don't want to waste because that costs more. But again, how much surface area like it would take to cover this Kleenex box, or if we wanted to wrap it with wrapping paper, how much paper that would take. So surface area is the covering on the outside of a 3-dimensional shape. And like for a cylinder, it would be how much like would wrap around to cover like our water bottle or like a soda soda can, like picture it like our bubbler that you guys are talking about, you know, like just the different cans if you wanted to cover that shape. So, we talked about our prism a little bit yesterday. So again, just kind of rehash that. So it's a 3D shape, and it has two congruent parallel bases. Now, it won't always be seated on its base. So I could draw my, you know, my shape so it's not seated on the actual base. So, but in this case it would be. So the bases in this case would be our triangles here. So in a prism, the bases are always congruent to parallel. And remember, congruent means exactly equal. Now the lateral faces are the sides. So now like my Kleenex box has multiple things you could call the base. Now you could call it like this, you could say the base is like this, but typically we don't leave a Kleenex box like that. So this is our Kleenex box, this would be the bases, would be the top and bottom, the rectangles. The lateral faces are around the outside. So kind of like the walls, maybe if you're pitching this as a room, it'd be the sides of that. So basically all the faces that aren't bases. So like this shape would have like 3 lateral faces, so they're going around the outside. So they have triangles as the bases, and the lateral faces in this case would be rectangles. Now, if I wanted to find the lateral area, and that might be something they do sometimes if they're covering, maybe they want to leave the top and the bottom open of something, they're just covering the outside, or like a dog kennel, like maybe they just want to put like maybe some windproofing on the sides of the dog kennel. Those would be the lateral area, so that's just the area of those faces. So the lateral area would only be the area of the lateral faces. So in this case, it would be 3 rectangles. Now this textbook, from when I taught at a previous school, they talked a lot more about the lateral area, and we spent more time on that. This textbook does not. So I mentioned that, but I don't think really the lateral area is brought up much in what we're talking about. So just a heads up on that. So I think that definition was in there from when I've taught this class at other schools. So now the surface area is covering that whole Kleenex box now. So now we want to cover the whole thing, so it's all the areas, so the area of all the faces added up. they learned to open our pantry doors. And they've been helping themselves to eating out of our pantry. So we have put child lock on our pantry doors this morning because the dumb dog is eating like all this stuff. And I think it's just the one dog, because she was like she was having an upset stomach last night. She ate too much out of the pantry. We come home and just like, there's like bags ripped open. And, what? Yeah, no, that was Zippy, just freaking out. Being rowdy.
Yeah, I thought that was pretty.
He was like banging on the glass. All right, so the surface area we're talking about again is we're trying to cover this whole box with like exactly the right amount of paper. Now this one obviously overlaps a little bit. Like let's say we want to use the least amount of paper possible. We would find the areas of the top, the bottom, all the sides, and basically it's just finding the area of a whole bunch of different polygons. So like in this problem, the bases are each triangles. So I would basically have 5 different areas to add up. So when you guys are ready, we'll flip the page over. So this is kind of what I'm talking about in terms of like picturing like what kind of paper, if we want to use like one sheet of paper to kind of cover this and make this into a 3-dimensional shape. So, and you probably have done this at some point where you folded something up, kind of a little bit of origami-ish, that we would unfold it and it would look like this nut that they call it a nut, is if I unfold that 3-dimensional shape with exactly the right amount of paper, it's gonna end up looking like this. So that would allow me to use, the minimum amount to cover that shape. So what they're asking us to do is finding the surface area. So we're gonna find the area of all these shapes. So that means we have to find the area of 1, 2, 3, 4, 5, 6 shapes. But good thing is that they're all just rectangles. So we're basically just doing base times height 6 times and then just adding them all up. Now that obviously, we're gonna learn a formula in a little bit that's gonna save us a little bit of time. But maybe like labeling some of these, it's 5, we have 6, 5, 6. Okay. So and I might kind of like highlight them as I go here. So we have, 5 times 6 here, so we have 30. Then I have 2 times 6, which is 12. And then I have the same thing a few more times here. So maybe saying like if you notice that there's another one. Oh no, that's a 5 and a, sorry, only 2. So this one is double. There's 2 of that, so that's 24. There's another 30. That's 60, and then the other one is double, right? Yeah. So 2 times 5, 2 times 5.
On questions like this where you notice like that version is like unfolded.
In the homework it is like that, yeah.
Okay.
But we're gonna learn a formula that kind of bypasses us having to do like breaking it down that way. Because so I think what she's getting at is the question is, what would like being able to picture what this net looks like is pretty confusing, unless you're a very visual person, like realizing that unfolds that way. So a little bit tougher in that case. But we end up with is that 104.
Yeah.
And remember, this is surface area, so this is going to be centimeters squared. It's 2-dimensional, so it's not 3-dimensional, so it's not centimeters cubed. We'll get into that with volume. So centimeters squared, this is going to end up being like a sheet of paper. So it folds into like a shape, but again, I could unfold my Kleenex box and it's going to be a certain amount of paper that we need. Okay? So we're gonna talk about our surface area, our formula that, again, we're gonna kind of bypass this. So if it's a net, it works pretty easily to do that. But our surface area of our prism, what's he up to?
I don't know, it's upside down.
He's going behind his tank.
Oh, he's hiding. Okay. So I say there's an easier formula with this, then this is what the formula looks like. And you're probably like, I don't know what, like, you know, maybe those are. So hopefully you realize, obviously S is the surface area. Any idea what capital B is?
Base.
It's the base, but it's something special about the base. The reason it's capital is a special reason. So it's actually the area of the base. So knowing how to find whatever the base is, we're gonna find the area of it. And the reason why we're multiplying it by 2 is because there's 2 bases. So both of those areas we have to take into account. Now P is the perimeter of the base. So that's like the distance around it. And H is what we know it to be as height of the prism. So not quite as straightforward maybe as you'd like, but at the same time that means we don't have to take it apart and draw like a net from it, but we'll talk about how to do this. And like I said, I think we'll probably break this into 2 days. We'll probably do prisms and then cylinders separately. Okay, so we'll probably do these 2 examples, and then wait for cylinders. All right, so this one's a little bit confusing because the way it's set up, it's not sitting on its base. So technically, what is our base of this shape? Or what is the shape of the base in this drawing?
Rectangle.
It's a rectangle. So the bases are or no, it's not a rectangle, sorry. The bases are the triangles, sorry. Hey guys, so remember, the bases in this case would be our triangles because remember the bases have to be parallel and congruent. The rectangle can't be the base because it's on the bottom and it's not parallel to anything. So our base is actually the triangle here on the bottom. And I'm realizing you might want your chart back if you would like it. We'll talk about that in a second because we need to know how to find the area of this base. Okay? So you have to kind of picture that this is not sitting on its, it's on its base. Oh, and I kind of. So what we're picturing here. So if this wasn't as crooked, this is kind of what it looks like right now-ish, and we are kind of picturing it would actually look like this. So we have to figure out, so our formula is S times 2B plus pH. We have to figure out big B. And since our base is a triangle, we're going to do base times height divided by 2. Now in our triangle, base times height, what's our base and height? 6 and 7. They give them to us. 6 and 7 divided by 2. 42 divided by 2 would be 21. So this would be my capital B. Now we need to find capital P, which is the perimeter of the base. What's that? Yeah, the perimeter of the base. So we need the perimeter of this triangle. We have an issue with that though. we don't know the hypotenuse.
That's every.
Thank God we have the Pythagorean theorem. I know you, I'm sure you know, in your prayers every night you think. For Pythagorean theorem, gosh, what would we do without it?
That's a different. Wait. Oh, we can add it up to two. I keep thinking we have to multiply. So used to multiply. Yeah, but
So,
I hate the term.
I found the perimeter of my base, well, I found my C is 8.8. And remember, we have to add up all the outside edges. So we're doing 6 plus 7 plus 8.8 for our perimeter. So our capital P is 21.8.
Isn't 7 squared 49?
Yeah.
It is, oops, thank you. It's for not just trusting me. I don't know why. 6 times 7 is 42, are you proud of me for that? I don't know, sorry. Just doing a different math problem up here, gotcha. All right, thanks. April Fools. We're gonna go with that. 9.2, that's better.
6. 22. 2.22.
22.2, lots of 2's. All right, so that's our capital P. What's our H? What's our height of our prism? Yeah.
10.
It's 10. So the height of the prism, remember this is kind of turned on its side, that's our height of our prism. So that's our H. So now when I go to put all of this into our formula,
There's a lot of twos.
lots of 2's.
Yes. Too many.
Too many.
I didn't try to do that.
And so remember our surface area is going to be units squared. So I believe we end up with 264 miles squared.
There's a 0.2 at the end.
Did you get a 0.2? I didn't.
I got, well, my answer for perimeter is 22.22.
Oh,
But then it
yeah.
rounded up to 9.
Yeah, it just depends if you do that. He's back here, coming by my bag. All right, we'll finish up with this last problem here, and then we'll alter our homework here a little bit. Good news is, this one's a little bit easier to find the area of our regular polygon. I can give you guys a little bit more information.
Might be heading for the door.
Yeah, he's trying to make us escape. Okay. So, what is our base this time? Okay.
The big rectangle thing. It's not the rectangle, it's the main thing.
The hexagon?
The hexagon, there we go.
I can't see.
Not quite a rectangle, but got
The
it.
rectangle thingy, I have thingy at the end.
Because there is a rectangle there, but the hexagon would be the base. So we have to find the area of the hexagon. So again, like I said, you might want your notes from last chapter. If anyone wants their chart back, let me know. We can always give that back. We need to find the little a here. So I have the hypotenuse is 5. This side is 2.5. I'm going to find little a. Hopefully I do my math correctly this time. I'm done with April Fool's jokes. So I got little a is 4.3-ish.
Hey, Louie, your feet, where your feet is.
Oh, he's like laying on your foot. Oh, he's going back to me.
The number of sides would be 6, and the side length would be 5. So our capital B is multiplying these all together and dividing them in half. I got like 65, 64.95. Depends how you round it. I kept my little a in there as a long decimal, So I ended up with around 65, 64.5 you might have gotten as well. Now remember, the capital P is the perimeter of the base. But that should be easy to find because this is a regular polygon, so these are all the same. So they're all 5. So our perimeter of our base would be 30. And then our height is the 12, because again, this is turned on its side. And they won't all be, but these all have been. And it, again, it just depends what you guys called exactly your capital B. Okay. So, we're gonna stop there for today, but we're gonna have to alter our homework a bit. So, we are going to, I might just tell you which ones to skip.
So hi, buddy. Grievance was.
You like, that's a turd.
So I don't know if it'd be easier to tell you what to do, so we're skipping those. We're doing 4, 8, 13, 15. So what we're doing is there, or what we're skipping. It's pretty much this, I mean, it's the same amount of writing. So whatever you prefer to